Hello friends, welcome to our channel. Let's have a look at problem 3440, reschedule meetings for maximum free time. This is the second of this series of problems. So you can compare this problem with problem 3439 for differences in assumptions. So for convenience, I wrote here some of the key points. I'm not going to read through the problem statement and also the constraints. So here I want to mention the two main assumptions. First, we can reschedule at most one meeting. The second is that the relative ordering of the meetings can be changed after rescheduling one meeting. So that's the two main assumptions here among others. So I would say the above two assumptions determine the coding logic. Before we do the coding, let me first see several key points. So this way, when you look at the coding, you can hopefully it can help you follow up. First is that in general for a meeting I, so here I changed the start time to be capital S and the ending time to be capital E. This is just for convenience, right? So let's say meeting I, so start at SI and ending at EI. So for this meeting, so if we want to consider rescheduling, so we need to consider if we can move it towards the free time intervals to its right or left, right? As such, we need to have two pieces of information. First, what's the largest free time duration to the right of meeting I? Similarly, what's the largest free time duration to the left of meeting I? So if we have these two pieces of information, so actually we know where we should put meeting I. So we just need to scan all the meetings to get the largest possible free time duration. Then that's our return, right? And then how to get the two pieces of information above. So obviously we can use a linear traversal to get the above information, right? So actually we can use some running variables, but for the purpose of teaching or demonstration, so I'm going to use some read with some redundancy. Our goal is to make the logic clear. So this is the point one. The second point is that how to get the largest free time, right? So assume that we have a meeting that is SI and EI, right? Start and end. So it's enclosed by the previous meeting ending time and the next meeting start time, right? So if I is 0, you can interpret this as a small number or 0. And this one, you're going to add it as the event time, right? That's what we want to see. So if we move the start time SI to the EI minus 1, the previous meeting ending time, then the free time we get is the duration, right? We have. That is the next start time minus the previous end time. That's the overall duration. Then minus the meeting duration. So this is our move rescheduling without changing the order of the meetings. So this gives us this free time duration. So this is the one possibility only because we are allowed to change the order of the meeting. So if we want to put the current meeting EI and SI to the left or to the right, and then there are two possibilities. First, if there are free time durations either in the left or right, as long as it has, that will be sufficient. If the free time duration is greater than or equal to the meeting duration, then we could move meeting I to left or right where it's proper. Then this block actually is freed. So this is the free time we can get, right? So this is the second point. I guess it basically explains the logic. So thirdly, we just need to find the maximum among all the two types of free times we can arrange, right? So here we need to do some special cases. For example, if I equals 0, we don't have EI minus 1. And also if I equals n minus 1, the last time, so we don't have EI plus 1. But you can pretend E negative 1 is 0. Notice that this is not the last element we consider for E, right? So also you can see Sn is the event time. That's it. So with that said, let me do the coding. So there's also some subtle point you need to pay attention to in order to make the process correct. First, I'm going to get the length of this s, right? So then I want to get a suffix that is 0 times n, and also prefix that is 0 times n. So let's look at the first right here. Meeting I, this is a generic meeting, and it will be start at SI, ending at EI, right? So it's enclosed by the previous ending time, that is SI minus EI minus 1, and the previous next start time, that is SI plus 1. So here, notice that I didn't consider the edge case when I equals 0 or I equals n minus 1, but we want to fix the generic case or idea. So the suffix I, the meaning is that, so the largest gap or free time to the right of meeting I, right? So similarly, you can interpret this one will be the largest gap to the left of meeting I. Then actually we can do a linear scan of this S and E to get all of those. Let's first fix the two arrays or two pieces of information. This is what we need, right? Information, as we mentioned above. So for the suffix, we need to do the linear scan from right to left. So basically for I in range n-1, this is the -1. So because we need to end at 0, we write -1 here, right? So first, if I equals n-1. So in this case, we're going to see the suffix I. So the free time will be the event time minus the last ending time, that is E of I, right? Otherwise, because we want the largest possible, including all the right positions, so it will going to be suffix I equals the max of the previous one. So here we can consider I plus 1. The reason is that I is less than n-1. Then we can see what current duration we can have. That is Si plus 1 minus the ending time of the current meeting, that is EI. So this is the prefix. And also we can get the, this is the suffix, right? We can also get the prefix. So for I in range n, right? So if I equals 0, so we regard the start will be 0, right? Then prefix I would be Si. So it's just write Si, or if you like, you write Si minus 0. So here I write minus 0 in order to make the logic clear. This is the one case. Otherwise, so prefix I will be the max of prefix I minus 1. It's legitimate we write I minus 1 because now I is greater than or equal to 1. And then what's the current duration we can get? So this is the start time of the current meeting minus the next ending time. So again, writing I minus 1 is legitimate. So actually you can print out this prefix and suffix. Print out this prefix. Let's do it. Prefix not defined. Prefix. Right. So if you look at example 1, right? So this meeting to the right, because we have 5. So anytime is 5. 5 minus 5 will be 0. So you get 0. And then if you look at this meeting to the right, so this is the 1. And 2 and 3 minus 2, that is 1. And the among 0 and 1, the larger is 1. So we get 1 here. So now if you look at the prefix, so you can look at the meeting 1. So this is the start time. This is from 0 to 1. This is the free time. So you get 1 here. So now if you look at this meeting, so 3 minus 2, that is 1. And the larger between 1 and 1, of course, is 1. So you get 1, 1 here, right? So that's the first example. Let's comment this out. So later you can play with this code. So yeah, you can get the things. So next, I want to prepare the return. Actually, once you realize these two parts or get these two pieces of information, the coding will be rather straightforward. But there is one detail you need to pay attention to. So first, I'm going to use for I start and end in enumerate. Because we are having this I, we are using enumerate. And also we have zip, S and E. You can see my previous video on the use of zip function, right? So we have this one. Then let's first set the low. The low, so we see what's the enclosing part for S and E. So in general, will be something like this, right? But we need to consider I equals 0 and I equals n minus 1. So this low will be 0 if I equals 0. Otherwise, it will be the end time of the previous meeting. And high will be event time if I equals n minus 1. Otherwise, it will be the next start time is Si plus 1, right? And after this if, so writing I plus 1 is legitimate. So here, after this I equals 0, this if, writing I minus 1 is valid or legitimate. So low and high is enclosing, so meeting I, that is S and E, is enclosed by, say, low and high, right? You can see something like this, S in coordinate, it will be something like low, start, end, and high, right? So then there are two possibilities. So we set this S, shift this SE towards the left to make S and low coincide, right? Or we shift S and E to the right, make E and high coincide. So this way of arrangement does not change the order of the meetings. So this way we have duration. Let's first do this. Duration is S minus E, right? So in this case, first we can make a comparison. The previous result state, and if we do such a movement, so no matter make S aligned with low or E aligned with high. So the free time we can get is high minus low minus duration. So this is just one possibility. And also depending on if you want to change, if the right or left have larger durations than the duration of this current meeting, we can put the meeting into that duration. So that's the case. So basically, if I is greater than 0 and the duration is less than or equal to prefix I minus 1. Notice that we need to consider I minus 1 because, for example, here in example 1, if you consider meeting started from 3 and ending in 5, in order to move here, you need to consider, so here is I equals 0. I equals 1, you need to consider prefix 0, right? And because this is towards the right, the left. So this is one case. And symmetrically, you also need to consider if I is less than n minus 1 and the duration is less than or equal to suffix I plus 1, right? For example, here, if you consider meeting 0, if I want to move to the right, so you need to consider suffix I, suffix 1, right? So in this case, we can make all the duration from low to high free. So in this case, we can make another comparison. So press result state and high minus low, right? And yeah, that's it. So now, after this for loop, we just need to return the result. So here, notice that there's a small detail, right? So this if arrangement in this block will change the order of the meetings, but pay attention to indexing. It's important. I minus 1 and I plus 1. You cannot use I and here in both places. So with that said, let's first do a testing. Let's see. Here it's not right. Let me check where is the problem. So here we have prefix, so prefix, suffix, so si-1 ei, that's right? And for prefix, that's also right, and max, right? And then let's look at the iteration. So we have this, and then low is this, and then ei-1, and high is event time, if I and otherwise. Then duration not s minus e minus s, right? So this will be right. Yeah, it passes the 4 test cases. Now let's look at generic case. Yeah, it passes all the generic cases. So here, let me do a quick comments. So first, once we have the suffix, actually this for loop and this for loop can be joined, right? So first exercise, compact the last 2 passes into one. So I guess this is a very easy exercise. So this is the one thing. Another thing is time complexity. So for this example here, if you look at this, this is the O of n, and this is the O of n, and this is also O of n. So overall, the time complexity will be O of n. So here, because I used this prefix and suffix, so the space complexity will be also O of n. I guess with that said, that's basically about it for the current problem. I guess the main thing to notice is that you first need to know what information you need in order to solve this problem. This is one part. So once you realize this part, basically you can roughly solve this problem. And then if you can pay attention to the small details, then you can solve this problem without difficulty. So with that said, I guess that's about it for the current video. Thank you for